Hello and welcome everyone. I'm your host Stefan Burns. Who am I? That's a good question. Geologist, geo guy, space weather dude, cosmic bro. Here to report on what's happening with our planet energetically, and today has been interesting. We had a magnitude 4.x earthquake north of Las Vegas, just outside of Area 51. I say 4.x because came in as a 4.7, was downgraded to a 4.4. All the magnitude submissions from different stations came in over 4.4. So I don't know why it's showing up as 4.4. And it's very shallow, just 4 kilometers in depth. So 4.4 to 4.7, why does this matter? Why am I spending so much time talking about the magnitude of this earthquake? Well, it's very shallow, A. B, it's following up after this magnitude 5.7 to the north in Nevada near Silver Spring. So we have a tectonic story here of how stress is being distributed out across the western part of the United States, and to get a movement here in an area of fairly low seismic risk. This is a felt earthquake in Las Vegas. People felt shaking for 5 to 10 seconds. Begs the question of, okay, do we perhaps have some sort of earthquake to strike California in the near future? Or at least is this a clue in terms of the direction of earthquake activity for the United States, the West Coast as a whole? Because every earthquake is interconnected and they basically paint a picture in a map. The other thing, though, is that earthquakes in nuclear tests are actually quite similar. They are different, but in general, they form similar resonance characteristics because it's basically just a big blast of energy. And earthquakes and nukes can have comparable energy magnitudes going up into the gigawatt hour scale. So when you see a magnitude 4.7 earthquake come in right outside Area 51, where they've done tons of historic nuclear testing. Let's zoom in on this location. Here's the exact epicenter right here in the mountains. You don't see anything here. Of course, how old is the satellite imagery is a good question, but you just see this dendritic fan of erosion coming off the mountains here. Well, if we go over, we will find other interesting things. We see Area 51 is just one ridge away. Look at this. You can walk that. I mean, it may be hot, but you can walk that. It's within walking distance. It's just a ridge away. Here's Area 51. I've done geologic mapping out in this sort of terrain before. And it's big in scale, but it's all connected together. And here is where they detonated tons of nukes. So Yucca Flat here. And this is absolutely pot-marked. Look at this crater here, generated by a big nuclear explosion. So there's a history of nuclear testing in this area, infrastructure of nuclear testing in this area. And the United States supposedly has not done any nuclear testing since about 1990 or 1992. And there is increasing talk right now of resuming physical nuclear testing to see effectively the state of the plutonium in the warheads. Because as it decays, right, it's not static, this is radioactive material. As it decays, it's generating light elements like helium, and this can alter the properties effectively of that warhead, that bomb. And so they have this whole stockpile. The United States, the Russians as well, all parts of the world have this huge stockpile that now, supposedly, for the United States, hasn't been physically tested in about 50 years. 30 years, about 30 years. And there's some questions as to whether it's still even good. And so some interesting seismic waveform signatures have come back from this earthquake. At least it's worth discussing in the context of, is this a covert underground nuclear test? Because it wouldn't be that big at a magnitude, let's say 4.4 to 4.7. It's not that large, but it would provide a wealth of diagnostic information. It's only 4 kilometers down. The deepest that's ever been drilled is 12 kilometers. Fracking regularly goes to 1.6 miles or about 3 kilometers. So it's really not that much further down than even just a typical fracking well. And they can go horizontal with those things too. So you could feasibly horizontally drill down then horizontally go down and have some testing done that no one would really be the wiser for and mistake it for earthquake if the seismograms tell that story. So a lot to cover in today's video. Hello and welcome everyone. We are going to do a question and answer after the report and this exploration into effectively this rabbit hole. I don't claim to have all the answers. I'm just exploring into this, and I have an open mind. I'm also skeptical, so we explore from these angles. But certainly there's quite a bit of talk about resuming nuclear testing. So here we have some of the history. We'll look through this. Step inside the secret lab where America tested its nukes. And just northwest of Las Vegas sits an area, basically. They did all the nuclear testing here in the past. This is at the Nevada test site. And I'm not sure which one this is. Maybe this is Encore. But they did hundreds of tests there. We'll look at the seismic data. We see all these nuclear tests spread out, all these diamonds. These are all nuclear tests across a few decades. And there was tremendous radioactive fallout from this. So we can see that right here. This is the radioactivity spread out from Area 51 across the continental United States with 20 years of testing here. So there's a rich, long history of nuclear testing from this location, and earthquakes there aren't that common. Now, I guess at the outset, I don't think this earthquake was a nuclear test. If we look at the seismic waveforms, it doesn't appear to be the case. So there is one that does look like it is. So we'll look at it. But it's worthy to talk about this effectively secret history now, because very few people ever discuss it. This has biologic effects, right? Cancer and other health issues, long-term disorders, which is quite serious. And then also we are entering this new phase of more distributed global warfare at higher intensities and posturing geopolitically. So this is worthy of consideration. So again, we'll do a question and answer after the report. Just if you're new here, and if you're watching this on replay, then you can skip that timestamp anytime to give that a watch. But let's look at this earthquake here. We'll start with our USGS latest earthquakes map, and we zoom out. We see all the earthquakes for the past day, and actually quite a bit of activity. You can see the different fault lines effectively with this. So of course you have California. You see parts of the Garlock Fault up here, and then you see how this is stretching across all the way to the eastern edge of the Great Basin. This is all normal faults in here. Extension, the ground is effectively spreading apart and sinking to some degree. So this huge basin here, a lot of tectonic activity, which is why it's important to consider. If this is a normal earthquake, doesn't mean it's unimportant. It's still very important as it relates to this tectonic picture. Then a good amount of activity today in and around Los Angeles here. Here we see a magnitude 3.0, 1.4, 3.0. Quite a few, just always scattered about. But, this 4.4, they have it labeled, being the biggest in the continental U.S. for the day. And then here's our location, Silver Springs, still swarming. Even though that main 5.8, I believe, was back on the 14th. So here we are 2 weeks later, and it's still swarming. We can look at our 30-day to see this. We'll put it on 2.5 and greater. We have a lot of earthquakes on the map right here. We see the 5.7, 4.8. This is the other reason I'm discussing this, because this 4.x that occurred today is right in that aftershock range for this 5.7. So, and there's the 5.7 right there. So it does seem that they're connected together tectonically. Walker Lane goes from here down to the Garlock Fault, but we do see effectively some sort of structure here as well, right? You can very clearly see that with all the normal faulting, where here you get a bit of a, I don't know, just like a depression. I don't want to call it a canyon, but you can see that topography is flatter there, whereas you have all the normal faulting to the north and you have more and desert stuff to the south. So here's the 4.7 or 4.4. Let's check out the data here. This was a felt earthquake. People talked about this. I posted about this on X. I can maybe pull it up. But if we go to our origin here and click on magnitudes, we see they chose 4.41. And you see here 4.7. That's what initially came in as, what I reported on because I saw a rise that came in. And then if you watch my cursor, here are the different magnitudes that came in. The magnitudes that were reported were all greater than the magnitude that was then eventually chosen, 4.41. We even had 2 listings here at magnitude 5. And considering how it was felt in Las Vegas, in some of these high rises swaying 5 to 10 seconds, it's not a 4.4, I would say. Las Vegas is 70 kilometers away? Maybe 70 miles away. I think 70 miles away. It's a good distance. We can measure it out really quick. Let's just quickly measure this out. And we'll go from our epicenter here. Yeah, so it's 70 miles away because we have 110 kilometers here. So you can switch this over. Yeah, I mean, it's a good distance. So that's the first thing. It's important to review these details, and when that's being fudged with a little bit, seemingly, you kind of pay attention. That's what I noticed, because I first posted about this at 4.7, then immediately revised pretty quickly, even though the other data suggested otherwise, down to 4.4. Here we can see the seismicity for this area. And we can see where we are. Here's the 4.4. It's not an area of high risk. This is based off of peak acceleration. You can see it right behind me over here. So peak acceleration is expressed as a percent of gravity. So this effectively shows you like the seismic hazard of an area. And we see the Garlock Fault really nicely coming up here. We see Walker Lane going all the way up. Here is the Silver Spring Swarm right there. Here's a 4.4. Now you do see this lobe. It's connected into that, but you don't see any super clear fault structure in this area. So there's a whole bunch of normal faults basically, and nothing super long or contiguous. I mean, you kind of have some faulting here like this. You have a little bit of faulting like that, kind of the shear zone going through a little bit. So that's all. This is all effectively like a shear zone. That's what it's all connected into. But it is an unusual place to get an earthquake. If we look at our earthquakes here, this is our master timeline going back to the year 1900. We see here this earthquake, and yeah, there's some nearby, magnitude 5 nearby right there. But really, this is a pretty empty area. So it's notable when you get a quake there. As you can see, this whole zone there is pretty empty. If you go further over, you get some more magnitude 5. That's a 5.3, 5.9. Okay. Here's where all the nuclear testing is, right? Look how close it is in proximity. All that nuclear testing right here. Interspersed with some regular earthquakes as well. There we go, like that 5.7 in 1975, right? 5.7 in 1985. Interesting that they're the same magnitude. You start to wonder, did they ever start to do this testing covertly? This earthquake here saying it's down at 0 kilometers depth. That's weird. And this one here showing 0 kilometers of depth, and that one there showing 0 kilometers of depth. Oh, this is kind of odd. Did they forget to change the database or something? 5 earthquakes going from 75 through 89 at depths of 0 kilometers. So basically at the surface. If you look at these nuclear explosions, you see that they all have depths similar. They're always all within a kilometer. And they're going to be at 0 unless they do an airburst, right? So there's some weird things that have obviously been happening here. I mean, I don't think I have to really even say it. There's Area 51 here. This is like one of the weirdest places in general. So when you start to discuss, and I don't really know that much, but if you start to discuss this part of the United States history, you got to open your mind up a little bit to some of these alternate possibilities that exist. And there is some, covert stuff happening. So if you wanted to test your nuclear stockpile and just to see how your plutonium is going to react with some of these helium bubbles and such, this would be a very good way to do it. To drill down below the surface, detonate a small amount, simulate a magnitude 4 something earthquake, and just basically let the data go underneath, the public perception, and you just don't do it too often. It's not like you're setting off thousands. You're just doing like strategic ones every now and then. So you're not completely clueless as it relates to your big trump card, which is the nuclear arsenal. At least that's one of them, right? So we can look at the seismic waveforms for this. And here we are. Let me also pull up another graphic for you showing the difference in seismic waveforms between a nuclear explosion and a actual earthquake, because they do differ. That is one key diagnostic tool, as would be radioactive isotopes, and you can kind of measure this stuff and using sonograms, and there's a whole bunch of things. But this would be one of the most important ways to figure this out, and well, we can do so. So here it is. Nuclear explosions versus earthquakes. We have two examples. They're both from North Korea, because they detonated nukes in the 2010s. And they did them underground too. So it's really a perfect test example. This has been done before by governments. It's not like this has never been done before. This has been done before. So here we see the nuclear test, and you see very strong, high intensity waves right at the beginning, and also very soon afterwards. This is time in minutes. So this is right around the 1 minute mark, okay? Basically, you have a lot of P waves, strong compressional waves going out in all directions from the nuclear blast, even if it's underground. Here we see an earthquake. Earthquakes are different in that they have a resonance effect, and most of their energy comes in the form of surface waves. So their P waves are quite small, their shear waves are quite high, and then their surface waves are quite strong, where you do not see that signature with the nuclear blast. It's mostly P waves and then this long, just moderate noisy rumble afterwards until it fades out. So there is a clear, distinct difference there. If I turn myself off, we can see the other example here on the right, and again the top panels for a nuclear blast from North Korea, I believe, and the bottom one is of an earthquake of comparable energy magnitude. And again, you see how nuclear blasts will have their energy pushed to the front, whereas earthquakes have their most intense phase of energy release later on in the earthquake, with the surface waves. And that actual travel time depends on where you are in reference to the epicenter of the event. So yes, earthquakes have 70% of their energy naturally in the surface waves, whereas the majority of energy in a nuclear blast is in the compressional front, generated immediately afterwards. So let's go back here, and we have our 4.4, as they call it, on the map here. This is the SAGE network, where you can start to actually see some of these seismograms. This is the epicenter. Here are some of these sites nearby that registered this earthquake, okay? You see them kind of spread out. There's even some further to the north. It looks like the closest one here is Mena, Nevada. And if you click that, we do see, one thing to note before this is that here we're looking at the vertical displacement. See how it says up-down ground motion? And this is the same, up-down ground motion. So we're most interested in looking at the vertical displacement of this, okay? Here we see the the different components. These are horizontal. This is east, east-west, north-south, and this is our vertical component, our Z component. Well, this site here picked up a response that looks odd. Look at all that strong energy right at the front, the compressional wave. That's very, very bizarre. And definitely not natural looking. Now the horizontal components show more surface wave velocity there, but this BZ component showing strong vertical compressional wave and not that much surface wave activity, which is kind of odd because the surface waves are this rolling motion where they really get going. And the fact that they are not showing up nicely for the site closest to that earthquake is bizarre. We can look at some seismic animations here. And so here we see the effect of a P wave like this going across. And it'll then show us shear waves after we see these compressional waves. Again, these are fast. These are the fastest waves of all of them because it's just a really quick motion for these molecules and elements to bump up against each other. Shear waves are different, and you don't have shear waves travel through anything liquid. They're not able to shear through a liquid. So here we see shear waves going across. Well, after this, we will see surface waves. And there's two types of surface waves. We have Rayleigh waves and love waves. Rayleigh waves are vertical surface waves. Love waves are horizontal surface waves. We don't see these as often as Rayleigh waves, but these can be very destructive as it relates to earthquakes, specifically big earthquakes, because that shaky motion can really move something off of its foundation. Rayleigh waves, as you can see, are this vertical surface wave. For an earthquake, the majority of the energy is going to be in this sort of wave motion. Okay? That's a Rayleigh wave. Now, again, as it relates to this, here with our vertical component, we see a strong compressional front, and then we do see these surface waves. But it's a bizarre signature. Let's look at some of the others. We'll go back to that one perhaps. But let's look at this one here from the Art Center College of Design. This is in Los Angeles. And these look much more like normal earthquake signatures from California. Here we see the compressional wave, shear wave, and then the surface waves come in. You see that this looks a lot more like this graphic here, right? It looks a lot more like this than the last one, which looked like that. But the first one that we showed was the seismogram in Nevada. Let's go to the one right below it here, Pinyon Flat. And again, we see earthquake-like signatures in the waveforms. Though you do see some strong compressional components there, a little bit stronger than you'd expect. We can look at it from Tucson. Here we see the strong surface wave components. And let's go to this one here, Columbia College, close to Pinyon Pines, or close to where we were looking at Minas, Nevada. I haven't seen this one yet. This is the first time I clicked on this one. This is weird. That's a strong compressional front. So, well, it's really saying the red line is the compressional wave, and it's saying that these are the shear waves. But this is odd. This is quite odd. So we have two now in this direction going out this way to the west that are showing strong compressional fronts, whereas to the south-southwest, we're seeing more surface waves. Keep in mind you have all the fault structures in here. So you have the Garlock Fault and Walker Lane and all this shear in this area, which would alter the characteristics of what you're seeing. The surface waves are probably going to be the main thing that allow you to get through that. If we look at Albuquerque, let's see what pops up. I haven't looked at this one yet. Here we have Albuquerque, and it's probably in the middle in terms of, it's pretty strong right there. But it does have, clearly the surface waves are the most intense and strongest waves coming in from this. But again, look at the difference. A normal earthquake really does not show that much until the surface waves come in. So you shouldn't really be seeing probably distinct pulses before that. Here you see really this clear, distinct double pulse signature, right? So overall, it looks like this was an earthquake, but there is some, at least to me, some ambiguity, especially from that Minas, Nevada one right here, or Mina, Nevada. This one's weird. This one looks like it could be very well. I mean, look at that compressional front. It is very strong. This is our closest seismogram to this location. So we have that. We can talk about Area 51 nuclear testing a little bit. And during World War II, there was an intense arms race occurring, meaning developments in weaponry were happening by the minute. The United States developed the first nuclear weapons during this arms race, and in the 1940s, specifically 1945, is when we started dropping them on the continent of North America. Because, you know, we dropped 2 bombs in Japan, but then we started testing them ourselves. The mission of the Area 51 test site is maintaining nuclear agency response capability, applying environmental restoration techniques to areas affected by nuclear testing, managing low-level and mixed radioactive waste, investigating demilitarization technologies, investigating counter-proliferation technologies, supporting work for others, programs, and Special Department of Defense activities, operating hazardous materials spill test center, and providing for the commercial development of the site. So that's everything that you would need for a nuclear testing site, right? This hasn't stopped. All the industry of it. Now, maybe the nuclear tests haven't gone on since the 90s. If you choose to believe that, I don't know what the truth is there, whether that's the case or not. I don't know. I don't think so personally, but I don't know. But clearly you have all the nuclear infrastructure at Area 51. That's the thing. It's right there. So it's coincidences keep piling up. So some interesting things here as well. We talk about going underground, and basically they were working on a facility, or they are. Yeah, the work is taking place in a facility known as the Principal Underground Laboratory for Subcritical Experimentation. And from the surface, it doesn't appear to be much, but it's quite a whole lab, as you can see. Here we see our nuclear testing, how it ended in the 90s, only North Korea really picking up in the 2010s. This is the official data. Okay, so take that for what it's worth. The decision to halt testing came about at the end of the Cold War, but the tunnels stayed open. The U.S. still needs to ensure that its nuclear weapons are safe and reliable. So they started to embark on a new program of testing nukes without actually setting them off. They did this with very advanced mathematical models. And they also have been practicing stockpile stewardship, because obviously it's not like we just put these things somewhere and totally forget about them. There's a whole industry around the nuclear stockpile. And at the end of the 90s, it would be true that you wouldn't need to do nuclear tests for a while because you just did all of them, right? So you just did a bunch of testing, developed some pretty wicked stuff. And yeah, you wouldn't need to keep testing it every single day. It's like you just put a kitchen in. You don't need to make sure the faucet's running every single day to ensure the kitchen works. Like, you just use it now. So the thing is, these experiments that they're doing to verify the integrity of this stockpile is very limited. Again, these are like mathematical model runs, simulations. We don't really know, well, who knows? But if they haven't tested, how well are these things going to perform if they need to be used? God forbid. So there's a lot here. Here's some interesting stuff to discuss. Plutonium makes up the core of America's nuclear weapons. Much of it was made decades ago. It's getting old. The oldest plutonium samples are about 80 years old. And as plutonium ages, it decays radioactively, releasing these helium atoms. these atoms can form bubbles and damage the plutonium's metal structure. And they don't know how those helium bubbles or the damage to the lattice have an impact on the response of the material. So that's the big thing. They have been basically now X-raying some of these warheads to try to examine their features and see their integrity. But there is another experiment going on that is to test plutonium later this spring. This was written in 2025, I think. What was this written? January 2025. So this, I guess, was done last year. And this experiment is called Cygnus. Now, if you've been watching the channel, we've been talking about the giant radio flares from the constellation of Cygnus, specifically microquasar Cygnus X3 within our galaxy. So that's a synchronicity, that you have Cygnus X3 in the constellation of Cygnus exploding with two giant radio flares in January and April of this year, 2026. And there's this top secret, I guess, arguably the most secretive scientific project in the United States government called Cygnus. Now, I don't know much about Cygnus, but that's just an interesting synchronicity I can present to you. If you want to learn more about these giant radio flares from Cygnus, you can just type Cygnus on my channel search bar and the video should pop up. And then you can discuss the larger geopolitical machinations that are occurring right now as it relates to nukes and nuclear testing. Some of these treaties are kind of slowly getting ripped up, and other big geopolitical players would love to resume testing because they're in similar situations. So Nova Zemlya, which is an interesting landform peninsula off the coast of Russia, that's where they did a lot of their nuclear tests. They're fully prepared for resumption of nuclear tests, supposedly. So we can go to Nova Zemlya, see what it looks like up there. That means new land in Russian, by the way. So Novaya would be new, and Zemlya is land. So this is new land in Russian. And you can see it does look almost like some cool continent or something in the Arctic. I guess they've done a lot of nuclear testing here. I don't know if it's going to show up on Google Earth with imagery. I can't imagine they'd do it on the glaciers. I think they'd probably do it over here or something. But regardless, there's a lot happening right now. And when we start to get suspicious earthquakes, at least I pay attention. I think it's worth paying attention. At a minimum, it doesn't even have to be a covert underground nuclear test that they did. It could just be a signal for us to pay attention to this because it's relevant at this moment in time. The universe works like this. It presents things to you and gives you the breadcrumb to lead to the main thing. And we still have a tectonic story here. If this is an earthquake, which I do think is the most likely outcome, I'd say it's probably 80% chance it's an earthquake. Not 99.9 though. 80% chance it's an earthquake. We are seeing some areas move in Nevada, which does fundamentally allow for some movements here in California because these are all connected together. We're looking at the entire movement of the Pacific plate against the North American plate. And so that transform movement, the San Andreas, only accounts for, I think, something like 70% of the energy in the movement. A lot of it's distributed out through Nevada, basically. You see it very clearly right here. Well, let's go back here one more time and look at these. And let's go to smallest magnitude first. And if we go down, we see there, 1964, nuclear explosion, magnitude 4. Magnitude 4, nuclear explosion, which is the bottom limit that I set. So you have nuclear explosions that were detonated that had magnitudes less than the earthquake today. So it is 100% possible that that was a nuclear explosion. It's not like it's some fantastical thing and the physics doesn't make it possible or we don't have the technology or whatever. Like, it's 100% possible that it could be covert nuclear test, but of course it's not at all in the same location as the prior ones. Like, again, I'm like 80% that's an earthquake, but some of the waveform signatures on it were quite weird. So I wanted to present this information to you, educate you a little bit about it. I'm also learning this as well. We see that they did spread out. Here's a 5.3 equivalent magnitude nuclear explosion in 1969. There's another one right there, far away from the central cluster, 4.1. 1970. Here's one over here. Oh, sorry, that's a sonic boom. That's new. I don't know what that's from. And they did some nuclear testing further up here, if I remember right as well. There may be one or two scattered up here. Though I'm not seeing them. And the final thing to note with this is you can get big earthquakes. So if we go here, 7.1, Fairview Peak, 1954. Yeah, here's one of those ones hidden up there. 4.7, nuclear explosion, 63. You had about 9 years before that, a magnitude 7.1 strike Nevada. That's a big quake. Look at these big ones up here. Magnitude 6.5, 6.2. It's also 1954. Double sequence there, right? Here we have a 6.4. There's a 6.1. So there's been big earthquakes also in Nevada. So general just informational public awareness announcement, PSA, that we are seeing increased seismicity right now in Nevada. And in locations that are kind of unusual. So, wanted to present that all to your attention. Now we will do a question and answer. So if you've asked a question in the Q&A with the super thanks, I will answer that. We'll take some from the general audience first, but if you want your question answered 100%, then make sure you submit it as a super thanks, and I will definitely get to it. And so yeah, just hope you're all doing well. If you're new watching in, I'm your host, Stefan Burns, geologist, geophysicist, space weather guy, here just exploring what's actually happening on our planet. Open to new ideas, but also skeptical of, you know, where it's useful to be skeptical, because there's a lot of crazy ideas out there too that have no legs, that a lot of people just take 100% and incorporate it into their understanding of the world. And it's good to, you know, expand out to these other ideas and possibilities, but not if you're living in like complete fantasy land and it's not real. First question from Sarah from Evie is, what was the sun doing in 1954? Sun was busy in 1954. It was solar cycle 19. So this is another, I've talked about this quite a lot. I'm not going to go crazy in depth on this, but let me pull up the solar cycle progression so we can look at this. We have that right here. Okay, and we can go right to this big peak, which my arm is covering up. And it was starting to get active. So it wasn't active yet actually in 54, but we were about to have the strongest solar cycle since solar cycle 3. So this is solar cycle 19. 1954 was right back here at solar minimum right before the ascension upwards. And I guess I should turn you off so people can see that. There's solar minimum. Then we went right up. So right before the biggest, strongest solar cycle since the American Revolution with solar cycle 3 was solar cycle 19. Peter's asking, where are these in comparison to Yucca Flats? Yucca Flats. That is right here, I can show you. We showed this at the beginning, but we'll show it again. Here's the magnitude 4.4 right here. And here we have Yucca Flat. Yucca. I'm not sure which one it is. I like both. So let's just do a simple measurement going across. 60, 65, 66 kilometers. So about 40 miles, let's say. About 40 miles away. So it's not like just 2 miles away, but It's a good hike. Yeah, maybe it's a little bit more than a 1 hour stroll, as I was kind of saying earlier. But you can walk this landscape. Tough, but you can. And here is the biggest one right there, Sedan Crater. So really big stuff. And comment here from Cleveland, which is, do you know the investigative reporter George Knapp, who's searching things from Area 51, U2 to exchange some info? No, I'm not aware of him, but there's plenty of people looking into these things at a very boots on the ground level. I consider myself, I look at this from the geologic angle, the geophysical angle. They're really one and the same for me. And then also very much interest in history. Because, before I went to school for geology, I was signed up as a history major. And then I really just decided to start covering the history of the Earth rather than just the history of mankind. So history is almost just a subset of geology, at least in my worldview. So you can't study this stuff without also learning some history. And the moment you get history data in front of you, historic data, and then you get like geologic, geophysical data, and you start to see overlaps, that's when you start to have this story emerge. So, and this greater understanding of what is happening. So that's kind of where I am. But there's other people out there, folks, that you can tune into to learn more about some of these things from different perspectives, I suppose. So thank you for sharing that recommendation. Our moderator here saying nukes have very specific signatures they know immediately. I'm not sure they know immediately, but yeah, they do have very specific signatures. There are independent groups that are testing this across effectively different organizations, third party, and more. And there's more evidence to suggest that there hasn't been any nuclear testing done by the big boys, you could say, since the 90s, in comparison to the idea that they are doing covert nuclear testing. But that's the whole thing. If it's covert and they do a good job of it, it's like pulling off a crime, like or a heist, right? If you do a good job of it, they don't find you. Like what they did at the Louvre and stealing the big diamond or whatever it was, right? I don't think they found them yet. So that's the whole thing. If you pull it off successfully, you do. So I don't discount the possibility that it could be happening. And we should be looking at these earthquake signatures directly, as we're doing in this video, right? Inform the public as to what is happening, and everyone can then do more research into it, be better educated, and we can all come to hopefully a better consensus idea as to the reality of the situation, the truth of the matter. That's really the goal for me. And a comment here from Brian: if you don't learn your history, you're doomed to repeat it and repeat it and repeat it and repeat it. Yes, so that's the thing. You really need to, we all collectively need to learn this stuff to as greater degrees to really get a sense of where we are in the world. Because it's easy to have a hot take, right? Everyone nowadays got a hot take. And it's often like tribal, where there's some talking point that this little community and tribe has, and they can spit that hot take out there and think they're really cool and macho, and there's no way to disprove that thing because it's just oh so clever, right? Well, yeah, understanding something in detail and in depth is not a hot take, right? This requires a lot of nuance and being able to see all the different sides and perspectives of something, top, down, sides, in, out, like everything. Hot take is very one-dimensional. So yeah, learning history with an open mind and learning to disassociate who you are from things around you is kind of key to this. At least this is my philosophy that I follow. I don't connect myself to anything. It's really just what is really happening. Because if I don't see things clearly, I don't want to be connected to something that doesn't resonate with my vibe. Let's say one that's like super destructive or something, and that's not what I'm about. I don't want to support that thing. So yeah, we need to move past these one-liners, which everyone's tired of, and everyone knows that you're not smart for saying it, right? We need to move past that. Okay, we have a super thanks here from Brittany. Thank you so much, very generous. And one from Nierka Lopez, longtime supporter. Thank you so much for the super thanks. And Misbehaving 1979 saying, please watch. More scientists are joining in on this theory. For the past few years, they got a lot right. It's scary. Let me know what you think, please. Yeah, there are other people tracking this. There's a lot of interest right now, in fact, as it relates to tracking this for Iran. Because Iran often gets magnitude 4 earthquakes. It's a seismically active area. And so there are, sometimes you get a magnitude 4 pop up and people are like on it pretty quick to check out those waveforms to see what the deal is. And if Iran is pursuing nuclear technologies, right, they're going to have to test it. So that's the other thing that I just think of is like there is this immense desire to test these nukes by a wide variety of people and organizations. And to think that no one has done it is, I don't know, I just think that's statistically unlikely. I think it's probably been covertly done quite a few times. And the people that are getting critical, actionable data, like, oh, we know this is going to work, or we know we have problems here. Like, the best data is going to come through this. Scanning something with x-rays or running a numerical simulation on the computer is fundamentally not going to be as data rich as actually doing a test and getting some hard concrete data back that can tell you the actual strength of the blast and therefore its radius and size and the fallout amounts and all this stuff, right? If you were going to deploy this in a militaristic sense, God forbid, but let's say that is your goal and agenda, but you want to limit its scale and not have it be too big, or you don't want it to not do enough, I mean, whatever, right? You would need to test this stuff. So, Mesh, thank you for the super sticker. And Misbehaving with a follow-up, thank you so much. Brandon with a thought, thank you for the super sticker. And it looks like that is it for the super thanks questions. And in general, we have one more question here for the Q&A before I sign off, which is, do you think the fireball sightings and these weird earthquakes could be from Elon Musk's digging machine making emergency bunkers for the elite? That's a pretty out there question. No, I do think there's obviously construction happening underground. More than in general people know, there always has. You research into the history of underground structures in Europe, for example, it's fascinating. So yeah, I mean, there are, of course, secret underground installations. The question is how big are they, right? Some people call them DUMBs, which would be deep underground military bases, and some people think that every single earthquake that happens is another DUMB being taken out, which is, you can make up your own mind, but it's not grounded in any fact. But there are, obviously underground facilities and installations. The question is how big are they and all this stuff. So, but are the fireballs connected to this and Elon and the emergency bunkers for the deletes? It's an interesting idea. I personally don't think so. So thank you all so much, everybody, for joining in today. I hope you found this presentation insightful and helped you to learn a little bit more about this history, past, present, and future. Hundreds of nukes were dropped, if not more, in Nevada over a pretty long time frame, going from the 40s all the way up to, I think, even the 80s. I don't know where the absolute last tests that took place were for the United States, but rich history of testing around Area 51. Now we have a magnitude 4.4. We can really be certain. Closing message is that if all of a sudden we start to get like a lot of magnitude 4s in this area, then something's happening, okay? So this is almost just a data point in time that I've created for people to reference in the future, being like, okay, here's some history, here's some of the seismicity, the geologic factors, etc. But wait, we're getting like 10 of these magnitude 4s every year, whereas before this is the only one in that location for 126 years. What's happening? So that's really going to be key. You could also ask the question of like, well, are they going to stick to just that area, or are they going to set them off all across the United States? So these are all ideas that you can contemplate on more if you so choose. So remember to go outside, have a good day, spend some time breathing some fresh air, moving your body, going for a walk, get some sunlight on your skin, in your eyeballs, drink good clean water, eat healthy food. Sending you lots of love and light. Please take care of yourselves. I'll see you all in the next video.